do any. I used to, when I started this topic with some of my kids, I'd start off with like a fancy video, but we're not going to do that. Let's just get straight into it because a lot of the stuff that we're going to do right now in this session is stuff that you already have ideas about and concepts of. Okay, so we're skipping a chapter, which is 9a. We're going to go straight to 9b for this. Okay, so when it comes to networks, now if you think back to what we learned in matrices, so I might pull that up real quick, yeah, really quickly. Oh, where is it? Matrices. This is some of the stuff that we'd already done. Okay, you'd actually already done some of this in chapter 5. Which one was it? This one here. Networks and diagrams and matrices. So it's actually not that hard. It's basically building off this concept of network diagrams and dots and lines. Now, instead of dots and lines, which is what I've called them in matrices, there are specific names for them. Okay. Now, if you also think back to what they represent connections between people, could be between towns, it could be between like if you have a computer program, okay, it could be like this dot is connected to this screen. Okay, so if you press that button, this is what it'll show on the screen, for example. Okay, so that's basic concept of using graphs and networks. But think of them as connections between places. That's the best way because when we do networks in this topic, well, I'm going to be referring to that a lot. Okay, so a graph is basically, or a network, is what we just looked at. So you've got a bunch of dots and lines that connect them. That is a graph right there. Okay, and it's representing, like I said, connections. Now there are names for the elements of the things that you're seeing in this graph. When you see a dot, we refer to it as a vertex. Okay, so the vertices are your dots. Okay, think of them as your dots. They're the spots, or they could be the nodes. Sometimes it's called nodes in your textbook. Okay, and the lines are your vertices. So think of the lines as the edges. So the edges are referred to as the lines. So in this graph, how many vertices do I have? 3 vertices, there's 3 dots. Okay, and how many edges do I have? 2 lines. Yeah, they're just connected to each other. Okay, so they're pretty straightforward. I'm now going to stop calling them dots and lines. I'm going to call them vertices and edges. Okay, so keep that in mind when we do these topics. Vertices are the dots, edges are the lines. Okay, sometimes, as it says here, you might have a curved line. Okay, it doesn't have to be straight. And you also might find in some graphs, if people are a bit crazy, okay, let's do this. Some graphs can have crossed edges like that. Okay, or some graphs can be disconnected like that vertex there. Okay, so just keep that in mind when you do these sort of questions. Yeah, vertices are lines, edges are dots. Sorry, the other way. Vertices are dots, edges are lines. All right. All right, so here's an example. Let's state the number of vertices and the number of edges here. So we're looking at vertices and edges. So remember, vertices, dots, edges, lines. Let's see. Let's go with Zaid. Can you tell me how many vertices there are? Ooh. Remember, vertices are your dots, yes? How many vertices do we have? 5. You've got 5, yeah? You've got A, B, C, D, E. There's 5. Okay, and how many edges do we have? Let's go with Mia. How many edges do I have? 1. Good, let's count them off. Let me rub this out. 1, 2, 3, 4, 5, 6, 7. Okay, so make sure you double check. Normally when I count, I like to do this too. I might put a line and go as 1, 2, 3, 4, 5, 6, 7. Okay, bear in mind that this is one straight edge. Just because there's a line that goes through doesn't mean it's 2 different ones. Yeah, it's one straight edge there. So there is, what did I say, 7. Okay, so vertices are the dots, edges are the lines. Yes.
If there was a dot in the middle,
yeah,
make it 2 separate lines?
Yes, definitely would. So let's say there was a edge there, a vertex there, then that would now make it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you've added a couple extra lines there. Yeah, so good point.
So a dot can separate them.
A dot can, yes, but just make sure you look at it, yeah? Most of the time, it'll be pretty clear. So that technically would be one edge. Okay, let's move on. Now, the degree of a vertex. All right, so when we talk about degrees, let me just see how far we're going to go with this. Okay, and that'll be it. Okay. So the degree, now, a lot of terms here, but when we talk about a degree, looking at a vertex, okay, if I'm talking about the degree, all I'm referring to is how many edges are connected to that vertex. So if I ask Jordan, here is B, yeah? If I ask you for the degree, I'm asking you how many lines are connected to B. So if I ask you what is the degree of B, Jordan, what would you say? How many lines connect to B? Are you sure? 4, good. 1, 2, 3, 4. So the degree of B would be 4. Okay. If I ask you the degree of, let's go E. Okay, what would that be? Fahad, what would you say? Degree of E. What's the degree for E? How many lines connect to E? Good. So the degree of E would be 3. Okay. So long story short, with this part here, all it's talking about is how many lines connect to a vertex. A vertex. Now the thing is, one thing to keep in mind. I want you guys to draw this. Let's draw 3 dots here. We'll just call them A, B, and C. Okay. Now, and then let's just draw these lines that connect them. So our edges. So we'll go there, there, and I'm going to be fancy. Boom. Now, we haven't come across many loops before. Okay, but a loop, if you think about in transition matrices, there were loops there, yeah? Now, when it comes to a loop, it's obviously that a vertex is connected to itself. So if I'm asking you now, actually, let's list out the degrees. So let's go degree of A. Okay, Ryan, what would the degree of A be? 2, good. Degree of B. Tori, what would the degree of B be? 1, good. Now, degree of C, okay, now with loops, the interesting thing is they count as 2 degrees. Okay, so what, gosh, your name just escaped my head. What he just said, Gillingham, that's it. What Gillingham said is correct. This C, so the C vertex has a degree of 3 because there's 1 there, but this edge here counts for 2 because it connects, because it connects this way, but it also connects the other way. I can't get to it. It's too small. I'll just redraw it, sorry. It connects the other way as well. All right, so like I said, it connects this way, but then it also connects, goodness me, the other way, which is that way. Okay, so that has a degree of 2. So that means C overall will have a degree of 3. Okay, so keep that in mind. Loops count for 2 degrees. Okay, so that's what all this is saying there. Now, a couple things to keep in mind as well is that a vertex, you can either say it has a positive or a negative, an odd or an even degree. Okay, or the vertex can be odd or even. All right, Jordan. So if I refer to A would be a even vertex. C would be a odd vertex, okay, because the number of degrees is even or odd. Now, for B, because it's a prime number, I think they would refer to it as still an odd, okay, not even. Okay, so just keep that in mind. Degree of B would be an odd. All right, let's keep going. Okay, another thing to keep in mind as well, so this is really important to know, the sum of the degrees of the vertices. So if I asked you, what is the sum of the degrees for all of this? What would it be? It's all it's saying is I'm adding all of the degrees there. So the sum of degrees here would be adding all of this together. So Tegan, what would that be if I added the sum of all these degrees? 2 plus 1 plus 3 is? Good. Okay, so it would be 6. The sum of the degrees in this graph would be 6. Okay, that's what we're asking for when it's asking for the sum. Now, there's a trick way of figuring out the sum of the degrees. Here it is here. So all you got to do is, if you want to find the sum without having to count each dot individually, so let's say this one here, if I wanted to find the sum of this, there's a quick way of doing it. All you have to do is count the number of edges. So 1, 2, 3, 4, 5, 6, 7. That means the sum of degrees for this graph. So if it's 7, all you got to do is multiply that by 2. So it's going to be, for a formula of finding the sum of degrees, number of edges times 2. Okay, that's how you get the sum of the degrees. Now, if I was to do this the long way, which I'll show you here, it'll take a while to do it, yeah? But that's why we do this instead. So to do it the long way, you'd be going degree of A would be 1. Degree of B, degree of C, degree of D, degree of E. Okay, so let's list them all out. So the degree of A is 1, the degree of B is 4, the degree of C is 3, for D you've also got 3, and for E you've also got 3. Okay, so if I was to add all of this up, okay, the sum of this, okay, you don't want to be doing this because it takes way too long. But if you add them all up, what's that? 5, 8, 11, plus 3, 14. Is 14. But the short way, okay, is using this formula. Thank you. Okay, sum of all the degrees. So all you're doing, basically, the sum of all degrees is equal to number of edges times 2. So that would be, number of edges, we counted there was 7. And then you're just multiplying it by 2. And you get 14. So it's a lot quicker to do it this way when you do this, as opposed to doing it this way. Okay, because it takes a bit too long. So it's easier.
There is a weird design. Will the edge count as 2?
Yes, the edge will count as 2. So keep that in mind. So if I do this, boys, if I was to do this one, okay, sum of the degrees, oops. Okay, remember it's the number of edges times 2. So how many edges are in this graph? There's 3. So it'll be 3 times 2. So that would be 6, which is what we got here as well. Okay, so it's just a quick way of doing it. Okay, let's keep going. For these graphs here, find the degree, state which vertices are odd, use the degrees of the vertices to find the number of edges. Easy, okay? What I like to do whenever I work with graphs is always label the vertices. Okay, it's a lot easier when to work with them. So let's just label this. We'll go A, B, C, D, and E. Okay, same with this graph. Let's call it A, B, C, and the last one as well. Let's go A, B, C, go D, E. Okay, just label your graph. It's a lot easier to work with, especially when you get a question like this, if it's not already labeled. Okay, most graphs with the vertices should be labeled there. Okay, so for the first one, for this graph here, find the degree of each vertex. So what you want to do, okay, just going to write down the degree for each one. So degree of A, the degree of B, degree of C, degree of D, and then the degree of E. Remember, degree is the number of edges that connect to that vertex. Or for Tina that wasn't here, the degree is the number of lines that connect to that dot. Okay, that's all it is. All right, let's list them out. So the degree of A, let's see. Let's go Chelsea. What would the degree of A be for this first graph?
3.
Good. Anthony, give me B. 3 as well. Zach, give me C. Good. Kira, give me D. Okay, that's a tricky one.
So the loop counts as 2, right?
Correct.
Okay. 5.
Very good. 5. Yeah, you got 1, 2, 3. And this loop counts as 2. So 5. Oops. Okay. Let's see. Huckton, what's the degree for E? Good. 2. Okay, so that's that. And then stage which vertices are odd. Yep, just the odd one. So that would be odd vertices. You go odd vertices. So which one are they? That would be A. Actually, I don't need the brackets. A, B, C, and D. Okay, E is the only even one there.
Could you say just all on but
You could say that too. I think in year 12 they do want you to be specific with it. So just keep that.
Wait, this stuff?
Yeah.
So a loop is 2 edges.
Yes. A loop counts for 2 edges because it connects to itself twice. All right. Yep.
I got 18 for the first one, but I don't know what I did wrong.
Okay. 18 for the first one. What do you mean? Like the sum?
Yeah.
Okay. Well, remember the sum is all of this times 2. So let's work that out. So the sum of edges, let's count them. Maybe you may have miscounted something. So 3 plus 3 is 6, plus 3 is 9, plus 5 is 14, plus 2 is, where was I? 16. Okay, so it's going to be 16 times 2 because the sum, sorry, no, chop it out, just 16.
Yeah.
Just 16. So maybe you might have counted something a bit wrong there. And you can double check it. Okay, you could go 1, 2, 3, 4, 5, 6, 7, 8. What's 8 times 2? 16. Okay, so you may have counted. Yeah. That's what. But in the context of doing that formula, you just count it as 1. Remember, the formula is
Reason loop is counted as 2. It only connects to 1.
exactly. But when we talk about this formula, you don't have to count the loop as 2. You're just saying that itself
That makes sense.
is an edge.
Oh, you could have said that earlier.
Okay, I'm sorry. So now we're going, if you want to find the sum, you're just going to go, yep, 1, 2, 3, 4, 5, 6, 7, 8. Count the lines, multiply by 2. Apologies for that. All right, see if you guys can do the second and third one on your own, and then we'll go through it together. And that'll be it.